I'm going to share screen. There we go. All right, and there's my screen. Share. All right, now you guys can see my P2IJ page there.
Yes.
Okay, good. All right, there we go. Got it. All right, so let me just check a couple things. You can see the calculator I pulled up. Yeah, okay, good. And let me get the notes up. All right, so we're going to start 10-4. The way it's set up is really strange. They have one rule in our class and the other rules in the other class, but it really is just all together. So I'm not sure why they did what they did, but they, we're going to start with page 74 first because it makes sense to do so. So we're going to go to page 74. Let me get myself down here. A fast way to do this, unless I can minimize that. There we go. Maybe it's not going to let me know. All right, y'all can see my page there. It says 10-4.
Yes, ma'am.
Okay. All right. Well, we're talking about square roots, and then we're going to talk about, I don't know why they put square roots here either, but we'll just talk about them real quick. When we talk about domain, right, you can only take the square root of a positive number. So let me get my pen out. Okay. So obviously this is called the radical sign, right? And it means, when I take the square root of x, remember, just going back to a long time ago, this means x to the 1/2, right? But you can only take square roots of positive numbers. So, if I want the square root of 9, that's what they're talking about there. The square root of 9 is 3 because 3 times 3 is 9, right? The square root of 4, well, obviously that's going to be 2. So over 1, which is 2, right? I'm not sure why we're doing this. Square root of 5, when they have this, they're just talking square root here. All right, you can't simplify that because there's no number that's squared would be 5, but what you can do is approximate with a calculator. So I'm going to pull up my calculator. There we go. I'll turn it on, and you should know where the square root button is anyways, but if I turn it on, the square root's here in blue, so I press second and then square root and then 5, right? So it's 2.236 about, right? It's not a perfect number. Oh, I see why we're doing it. Okay. So the question they asked is the square root of 9 minus the square root of 4 equal to the square root of 5, because square roots have rules associated with them like anything else. And like the square root of 9 is 3, the square root of 4 is 2. That does not equal square root of 5, which is 2.236. So one of the more common mistakes that you see in algebra, so the square root of x minus y does not equal the square root of x minus the square root of y, right? There's just different rules. That's true for a sum too. Like if this were plus, that's not true here. So with square roots, there's only a couple rules. The square root of x times y. Now you can do it there. It's the square root of x times the square root of y. So those are okay. And division's okay with square roots. But you can't turn them into adding and subtracting, okay? So that's just a basic square root rule. Convince you that's true. All right, any questions? All right, I'm assuming I can clear this off. It's a little awkward not having that second screen. I can't see your faces, so. But anyways, all right. I'll clear all the drawings. I have to move on. All right, so, and we talked, so, obviously this isn't true either. No, here's the rules that we're going to talk about. All right, so here's my pencil. Here we go. All right, so, obviously this isn't true either. The square root of 9 is 3, the square root of 4 is 2. So you have to do the square roots, right? So it's not true. All right, so if they want you to evaluate something like the square root of 25 minus 1, right? What's in the radical here is what you're taking the square root of. So the square root of 25 is 5. You're going to get 4. All right, so. I'm not sure why. 3 square root of 1 minus 1 is what they want you to do. So the square root of 1 is 1, because 1 times 1 is 1. So it's 3 minus 1, which is 2. Okay. So we just talked about this little, oh, well, when you're dividing, the square root of 81 is 9, and the square root of 9 is 3. So I get 9 over 3 is 3. And 81 over 9 does not equal 3, right? 81 over 9, that equals 9. So you can't just cancel square root signs, all right? What I could do is say, oh, well, the square root of 81 over 9, rather than doing 2 square roots, it really doesn't matter. 81 over 9 is 9. So I say, oh, that's the square root of 9, right, which is 3, okay? So the point of all this is that there's certain rules that follow with the square root function, all right? And just like when we're getting logs now, there are certain rules that only are true for logs, okay? And they're different than what you're used to. All right, so I'm gonna clear this off. Okay, let's see how we're doing. Okay. All right, so with logarithms, a logarithm, the way that you think about a logarithm, it's the opposite. It's the inverse operation of an exponent. Okay, so let me get it here. In other words, they undo an exponent. So like, for example, if I take 3 and I square it, I get 9. And then if I take the square root of 9, I go back to 3. So a square root and a square, they're inverse operations. They undo each other, all right? So logs are the opposite of exponentials, which we're going to talk about and use shortly. All right, so to do logs, all right, you can do logs on a calculator, all right? So we're going to pull up the calculator, and we're going to talk about logs on the calculator. All right, here's my calculator. So they want me to find the log of 5. So there's a LOG button, and there's a couple other logs we're going to talk about. LOG is base 10, so it's this one. I just type log 5. And I get 0.69897, whatever. I get this number, right? Okay. So let me write it down. Oops. .69897. All right. So if I do the log 8 minus the log of 3, I'm just going to plug that in my calculator. So I'm just going to type log 8, close the parentheses, minus log 3. And I get 0.426 about. I'll just call it, I'll round it. All right, so are these two things equal? Obviously, they're not equal, right? So you can't just subtract logs. Like you can't, so this tells me that the log of A minus the log of B does not equal the log of A minus B. Okay, so you can't just split them up like they were parentheses. There are certain rules that you have to use, okay? And the other one's false true. This doesn't even make any sense. So you can't cancel or subtract out logs. You just can't do it. All right, so so what are the log rules? I'm hoping that's where we're going. Okay, so we're going to talk about logs. This is really an awkward way to start logs, but okay. Just a second, I want to see if we're going into the. We're not. Okay, before we go anywhere else, I kind of want to talk to you about what is a log, because they really should have this here. So what a log does is it undoes an exponential. So I'm going to get my pencil out here. Okay, so if I have something like y equals a to the x, an exponent. All right, if I want to do the inverse, the opposite, what I do is I do this log thing. I do log base a of y equals x. So I switch x and y, and this right here is your base. And so this is what they call the base of the logarithm. Okay, it's down, it's a subscript. And so when it's 10 to the x, when the base is 10, the log is base 10. Base 10 is kind of a default, so they don't write the 10 here. It's implied there's a 10. So it's log base 10 of y equals x. So you see I'm switching x and y, and then I'm keeping the base, all right? And so there's another type of exponential. I think we talked about e's in here, or you did in 1324. E is like a number, it's 2.714. And they don't write log base, they don't put a little e here, they put an ln. So they write ln, and so ln is the same as log base e. Okay, so an ln undoes an e, a log undoes a 10 to the x, and log base 8 undoes a to the x. So these functions, which we can evaluate on our calculator, have different bases, all right? And that's depending on the base of the exponent that we were looking at. All right, so if I want to evaluate the log of 10, I'm going to use the calculator, but what it's asking you, it's saying 10 to what power? The base is 10, really. 10 to what power is that number in the parentheses? So that would be 10 to the first. So just to show you on the calculator, if I take log of 10, I should get 1 because it's 10 to the first power, all right? So log is base 10. All right, I'm gonna plug these numbers in the calculator, and we'll talk about some of the things we see. So if I do the log of 1, I get 0, okay, which doesn't surprise me because, let's see, this, I know that 10 to the first is 1, and the log of 1 is 0, because I know that 10 to what power, 10, I'm asking myself 10 to what power equals 1, well 10 to the 0, anything to the 0 equals 1, so the log of 1 is 0. So the log of 8, I'm saying 10 to what power equals 8. Now I don't know the answer to that, that's going to be a decimal, right? So I'm just going to plug it in the calculator. So let's do the log of 8. All right, and I get 0.903. And then they want the log of 800, just to show you, 10 to the what is 800? Well, I know it's bigger than 2 because 10 squared is 100. So it's 2.9. All right, so one's about 0.9 and one's 2.9. Pencil. Now, when you have an ln, you have to use a different button. That's the ln, that's the base e. All right, so e to the what power is e? Well, that's going to be e to the first. I'm going to do it in a calculator just so you can see. So the ln, when I have an ln, I'm going to use the ln button, which is right below the log right here. And the number e is right here in blue, right above the divided sign. So if I do the ln of e, I'm going to get 1. All right. And I should just evaluate all these logs. Now the ln of 1 is 0. All right, because it turns out that I don't care what the log is. Whenever you take the log of 1, it's 0. That's a helpful thing to know when you're working with logs. Because basically e to the 0 is 1, right? Anything to the 0th power is 1. All right, so the ln of 8, let's take that. So what I'm asking myself here is 2 to what power equals 8. So let's think about that compared with the other one. 10 to the what power, that's going to be a lot smaller than 2 to the what power, because I already know that, right? Because 2 times 2 times 2 is 8. So 2 to the, oh, wait a minute, I'm not doing 2. What am I doing? It's e, but let me write this as e. Since e is about 2, I know it's going to be a lot bigger. So I'm just going to plug in the ln of 8 in the calculator, and ln of 8, just get them out of the way, ln of 8 and ln of 800. ln of 8 is 2.079, and ln of 800 is 6.68, 2.08, 6.68. All right. So, you can evaluate logs on the calculator. You can also evaluate logs with other bases. So I'm hoping we'll see what's coming up next. All right, sorry, I'm going to clear this. So the point is you have a log button on your calculator you want to get familiar with. Let's see, close that out to go down. Are we going to talk about other log bases? While I have a second, I'm going to talk about it. I might be coming up, but I just want to talk to y'all about it. Now, the calculator, so you can take logs of any basis. So if I want to solve something like, or if I want to talk about something like, I don't know, let's say 2 to the x equals 5. I have no idea what power of 5 gives me 2. 2 to what power is 5? I have no idea. I know 2 squared is 4 and 2 cubed is 8. So it's got to be somewhere between 2 and 3, but I don't really know. But I don't have to know, because all I have to do is write this in logarithmic form. And the way that I write this, I write a log, and the base is 2, so that goes downstairs, and I switch these guys. So log base 2 of 5 equals x. And if I could figure out what the log base 2 of 5 is, that would be great. Well, your calculator's got a button. Okay, which means I'm going to pull up the calculator. All right, so if you have an 84, if you have an 83, hang on with me for a minute. There's a different way to do it because they don't have this button. But if you have an 84, they have a log base button. There's a couple ways to get to it. If you hit the math button, I think it's under num, math num. And then I look back down to, do they have it? Nope, wrong place. Let's see, math. It's just straight under math. There it is, log base. So you see that? So I could type that, and the base is 2. See, it's down below, and the number's 5. So I just type it, and it's 2.319. All right, so that's one way to get to the log of different bases. So when you're working with E or 10, you have these 2 buttons. Otherwise, you've got to use the log base button. Another way to get to it is alpha F2 number 5. So that's the same button. They put it in several different places in the calculator when they did the add-on, but it does the same thing. So if you need another base, you're going to use that log base button. Now, if you have an 83, you don't have the log base button. All right, so what do? You do something else. Okay, so if you have an 83, what you're always going to do is when you have an answer like this, you're going to take the log of the big number over the log of the base, the small number. I remember the 2 was on the bottom, it's the base. The base goes on the bottom. So if I do log 5 over log 2 on my calculator, so if I do log 5 divided by log 2, you get the same number, all right? And in fact, it doesn't even really matter what button you use. I could use ln. If I did the ln of 5 over the ln of 2, I still get the same number, all right? So if you have an 83, all you're gonna do is take the log of the big number over the log of the base. Base goes on the bottom. All right. Oops. Let me clear this out. Where's the annotate? There we go. All right. If you have any questions, let me know, because like I said, I can't see your faces, so a little bit more of a struggle for me. All right, so let's talk about evaluating exponential functions. All you're doing is plugging something into a calculator. So function notation is something we've done. So when they're asking you to find f of 6, all you're doing is taking 6 and you're plugging it in for x. So I get 12.4 e to the 0.2 times 6 plus 5. And that's what I want to plug in a calculator, right? So I'm just going to do that. Pull up my calculator. I'm going to type 12.4. There's an E button. Where's the E? There's a nice E button down there. So if I do second and then the ln, e to the 0.2 times 6. Now, to get out of the exponent, you need to arrow over on the 84. See how it dropped down? Because the plus 5 should not be in the exponent. So if I enter that, I get 46.169. Okay, so I'm just typing these numbers into a calculator. All right, so if I want f of 15, I'm going to plug in 15 for x. So it's 125 log of 15 minus 5 plus 20. And again, I can just plug this into a calculator. It's an LOG button, so I want to make sure I use the LOG. Pull up my calculator. 125 log of 15 minus 5. Make sure you close off the parentheses there and do plus 20. And oops. All right, let me go back. I messed up. Let's put a plus there. All right, so I end up getting 145. Okay. So let's do this. Okay. All right, so you can graph exponential and logarithmic functions on the calculator. Okay, and pretty much by typing them in. We'll talk a little bit about windows though, because with exponential, they're going to grow really fast or decay fast. So you might have to adjust your window a little bit to get a good picture. So I'm going to go into y equals, and I'm going to type this function they want, which is 12.4 e to the 0.2x plus 5. Go down, plus 5. Now I'm going to do it in regular window, see what it looks like. So I hit zoom 6. All right, so you don't really get a good graph here, right? So it looks like it goes up. It doesn't look good. Should have a y-intercept. Oh no, it's got a y-intercept of 17. So one of the things you can do. Let's go to the table and look at this. Oops, let me change my table settings. Start at 0, and we're going to go up by 1s. All right, so I'm going to go to the table. All right, so, you can see at 0, it starts at 17 and it goes, it goes lower, but it doesn't go negative. And it goes pretty high. So I'm going to change my window. One thing, if you like, you can do, if you want to keep the window from -10 to 10, you can do this thing called zoom fit. Well, come on. Zoom fit, what it will do, it's not going to change the X window, but what it will do, it'll fit the Y into the window for the given values of X. So I'm going to hit zoom fit. And you can see now I have a nice picture, right? Exponentials, what happens, they start out flat and they increase and increase. They don't go negative because it's got a +5. It's actually, it won't go less than 5, just to kind of show you. If I scroll down a little bit in this table, in fact, I'll just do it this way. I'm going to start my table at like -100, just so you can see it. And if I go to the table, you can see like they're all 5. So they're not getting any lower than 5. So if I wanted to graph this, yeah, I could do that. I could do it that way. But exponentials all have certain characteristics you want to be aware of. So let me show you what the window is. So, I can adjust this. I'm going to change I know it doesn't go lower than 5, so I'm going to change my Y min to 0. Just so you can see that. And my Y max, I'll make it 100. Just to get rid of all those nasty decimals. So that's a pretty good graph. You can see the y-intercept. You can see that it doesn't get below 5. So there's a good window. Okay, and I'm not going to write it because you guys could do that. All right, so the x min is -10, x max is 10, y min 0, y max is 100. What you want to be able to do with exponentials is see that curve. You want to see it going up. Let's see, what is going on here? There we go. You want to be able to see that nice exponential curve. So like with this particular graph, I knew it didn't go below 5, right? And that's what they call it. It has a horizontal asymptote because it doesn't drop below it. And I know it goes up, right? And across it like 17 or something. But just you want to be able to see a good picture of it. So I did -10 to 10 and I did 0 to 100. All right. The point being exponentials go up fast, so you might have to mess with your window. Now, all log graphs and all exponentials kind of look like that. If they have a negative exponent, they're going to go down. But they just kind of have that shape to them. Now, logs are a little different. What all logs look like is they're going to have a vertical asymptote. Now, this one is shifted a little bit, so it's normally, if I were to graph just the straight log of x, it looks something like this. And the log of 1 is always 0. Now, this one's going to be a little different because this is a shift. You don't know your shifts maybe, but it's shifted 5 to the right. So it's going to look a little differently. But we're going to graph it on the calculator anyways, just to look at it on the calculator. So we go to y equals. I'm going to type that graph. So I'm going to clear it. And I'm going to do 125. That's a huge number. Log x minus 5 plus 20. I'm going to leave the window where it is just because there's some big numbers in there. Let's take a look at it. Okay, so you're seeing part of the log graph. You don't need all this negative stuff over here. So let's make x let's make it 0. We don't need to go that far out. And I think I needed some negative numbers since it went down. So I'll go from negative 100. I don't know, I'm just playing. Well, that's a pretty good graph. You can see what you can see from this. It's got that curve to it. It goes up. It keeps going up forever, but it's not very fast. And if you see at 5 here, there's that vertical asymptote that you see with log graphs. Okay. So, so that's a log graph. I'll give you the window. Here's the window I used, is 0 to 10. And I need negative 100 to 100. The main thing is here, you don't want to have x go negative because you can't take the log of a negative number. Okay, it doesn't exist. All right, and we'll talk more about that. Let's do this. How do I clear this thing? Annotate, clear. All right, so, we're going to talk about domain. All right, so with exponential functions, she's got pictures here of example exponents. When the exponent is positive, it's called exponential growth because it's going up. When it's negative, it's called decay. Okay. The one thing a couple things I want you to notice. These guys, they don't drop below 0. All right, so they have horizontal asymptotes at y equals 0. And they never actually reach 0. They're always just a little bit above it. The domain, if you look at x, it goes forever up, out, and forever over, right? So the domain of an exponential is all reals. So it's negative infinity to infinity. Okay, so no restrictions on domain. The range is what's interesting. The range, it always has to be positive. So the range is from 0 to infinity. We don't include 0 because 0 is the asymptote. It approaches it, but it never reaches it. Oh, that's not what I want. How do I clear this thing? There we go. All right, so she has all these questions and it's kind of crazy. So let me do this. I'm going to pull up the calculator and we're going to look at y equals 2 to the x. I'm just going to type it like that, 2 to the x. And I'm going to go to my table. I'm going to start at 0 though. Oh, that's not what I want. We start at 0. All right. So if I look at my table, like 2 to the negative 2, is it in the domain? Yeah. 0. You know, all these x's, they all have a y. So the domain of it's all reals. All right. So that's what the point she's trying to make here. All right. And you can even do it for fractions. It's not just that it's only good for integers. Like if I go second calc value and I ask it to do 2 to the 1/2, 2 raised to the 1/2. Oops. Value, I want 2 to the 1/2, so just type 0.1/2. So I get 1.414. So obviously it's in the domain to the -3/4. So I'll go back. It's like -0.75 or -3 divided by 4. Oh. I have to, with this calculator, I have to set the window so that that's actually in there. So I'm going to go from -10 to 10. All right, second calc value. So I'm going to look at -3/4. And it's got a value 0.594. So it's in the domain. If I look at pi/2, pi buttons here. Again, you can see that that's in the domain. So the domain of the function, all exponentials domain is always the same as solvers. 100%. All right. So one of the things I want you to keep in mind, all right, so with exponentials, we just talked about it, because now we're going to talk about logs. So the domain of an exponential is -infinity to infinity, right? And the range, if it's not shifted, would be 0 to infinity, all right? So if you look at logs, it's a totally different thing. It's the log. What happens with an inverse? You switch y and x, basically you do an inverse. And if you look at the graphs, are a little different depending on the base of the log. But let's graph them in the calculator just so you can see how that works. So I'm going to graph these in the calculator. Here. So I'm going to go to that button. I'm going to do alpha F2 log base. So I can actually graph them in the calculator. Log base 2 of x. I'll graph all of hers. Now, most of these, well, let's graph it. So it has, now you're going to see with the calculator, let me change my window. It goes down, it looks like it stops, it doesn't, it keeps going, all right, because the log of 0 is undefined. In fact, the more you zoom in on this, if I hit zoom in, you can see that it just keeps going, it doesn't stop. Okay, that's one of the downfalls. You can't, you have to understand that it goes all the way down, it always does. If she has a few other logs. I think she had log base 1/4. You can do that if you want. Log, oops. I do alpha F2 log base 1/4, so that's 0.25 of x. If I graph that, it's going to look a little different. It's kind of flipped, all right? But you can see these different graphs. I want you to notice that a log cannot have a negative base. All right, it's got to be positive. It's got to be greater than 0. Because if I did something like, oh, I don't know, let's do log base -2 of x. It's not going to like it. All bases must be positive. So if I graph it, it's probably going to give me an error. Well, it didn't do anything. All right, so I wonder what it. Let's go to the table and see what it does. I was curious. Oh yeah, error all the way through. All right, so you can't take the log of a negative number. All right, but I want you to notice that all those graphs, if you go down here, all these graphs have a few things in common in terms of their domain and range. All right, so if you look at this, the domain of this graphs are all the same. Format. So basically, if you look at all these graphs, they start at 0 and they go up. They don't equal 0 because they all have a vertical asymptote of 0. All right. So the domain of the logs are always 0 to infinity. Now the range, it goes down forever and up forever. So the range would be all reals. So if you compare that with the exponential that we had up here, let's see, the domain was negative infinity to infinity, and the range was 0 to infinity. So basically what happens is the domain and range just flip-flop. The domain and the range, they flip places. There's a reason for that. When you take inverse functions, you switch y and x, and that's why the domain and range change. But that's beyond probably what you need to know. So, okay. All right, and she's bringing the point that where you see those errors, the logs aren't defined. They're only defined for positive numbers. All right. So one thing I want to say, we've been talking about domain, and the log has a domain because you can't take the log of a negative number. So I'm going to do this slightly differently. So when I talk about the log of x, right, I know that x has to be greater than 0 because you can't take the log of a negative, it doesn't exist. So if I talk about the log of f of x, of a function inside those parentheses, this is a domain issue. You know that whatever in that parenthesis also has to be positive, all right, to get the domain. So with logs, you just take the inside and you make it greater than 0. So if you think about it, without a calculator on this guy, so pretty much by using that rule, I know that whatever's in the parentheses has to be greater than 0. So if I move the 2 over, if I add 2, I get that x has to be greater than 2. All right, so any number bigger than 2 is going to be in its domain. So a 0 in the domain, no. 1 in the domain, no. Now 2 minus 2 is 0. That's not good because it has to be greater than 0. So 2 is not in the domain. And then everything else beyond that would be. Okay? So with logarithmic functions, you must restrict the domain. All right? Just to show you on the graphing calculator. My graph, I'm going to graph the log of x minus 2. Pull all this stuff out. Typing log of x minus 2. All right, and if I go into the table, you can see for anything less than 2 or less, you have an error. All right, so it's not in the domain. All right. Sorry, I need to get this cleared off. All right, so you can't take the log of a negative number, which I've been telling you, can't take the log of 0, okay? So we talked about different bases. Now she's finally bringing it up. You can take different bases with the alpha F2, like we talked about, and do the log base. Okay. Change of base formula. If you do not have a calculator or TI-84 or an Inspire, you have to do the change of base formula. All right. So if you have an old 83 or something, you're going to have to do the change of base formula. She happened to pick the same example I did. So let me kind of rehash this. So if I want to take the log base 3 of 7, right, I can plug it in my calculator on an 84. On an 83, I just take the log of the big number over the log of the little number, and I just plug it in. So log 7 over log 3. So I'm going to quit. Type log 7 divided by the log of 3. And there's my answer. I can also, with the TI-84 or the Inspire, hit alpha F2, log base, and just type it. So log base 3 of 7. So whatever, it doesn't really matter, whatever you need to do to get those logs. Okay. So some practice for the TI-83 guys. Let's go down here. All right, so on the TI-84, I could just type them in. On the TI-83, all I got to do is take the log of the big guy over the log of the little guy. So I'm going to do the log of 11 divided by the log of 4. I don't have an 84. get 1.729. All right. We'll do a couple more. You can write those down. Log base 0.5 of 6. Doesn't matter what the base is as long as it's not negative. So on the TIE3, I do the log of 6.25. Oops. Divided by the log of 0.5. And again, you could use the log button or the ln button. It ain't gonna matter. Okay, so I got negative 2.64. You guys can try the last one on your own. And I'll do it here. You can either type it in with the log base button or do the change of base. Log base 1202. So if I just type that in my calculator, hopefully you get the same thing I do. Give me a minute. Log of 12 divided by log of 2. Notice it doesn't matter what log I use. All right. It does matter that I do it in the right order, right? I get the top number on the big number on the top, the base on the bottom. I did that backwards. ln of 2 divided by the ln 12. Base always goes on the bottom. All right, I get 0.279. Okay, so you just want to be able to evaluate logs in your calculator. You're going to have to do that in both 1324 and 1325. All right, so, you know, for inequalities, whatever, I mean, they're just trying to get you to write things in interval notation, which you've already done. You know, if I have x plus 5 is greater than 0, if I move it over, I'm going to get x is greater than negative 5. I like to write it on a number line. Here's negative 5. I'm not including it, so I use an open circle, and here's infinity, going this way. So in interval notation, it'd be from negative 5 to infinity. Okay, now be careful with inequalities. Remember, when you divide or multiply by a negative number, you must flip the sign. So, you know, one way to do this is to subtract 5. So I get negative x is greater than negative 5. So if I divide by negative 1, now I divided by a negative, so I need to use that rule. X is less than 5. Okay, I have to flip the sign because when you divide or multiply by a negative, you flip the sign. So drawing my number line, here's 5, and we're going that way. So with interval notation, I'm going from negative infinity up to 5. All right, if I solve this, I get 2x, move the 3 over, it's positive 3, divide by 2. I get x is greater than 3/2. Number line, here's 3/2. I'm going up, so we're going to infinity. So in interval notation, it's from 3/2 to infinity. Okay. Now, if you want to avoid negatives altogether, one thing you could do, I'll move the 3x over and make it positive. So I added it to both sides. Then I can divide by 3, and I get x is less than 3. Now, that backwards notation may bother you, so go ahead and fix it. The way you fix it is the alligator opens to the 3. So I'll do it that way. All right, so here's 3, and we're going down. So it's from negative infinity to 3. All right, that would be your solutions. All right, why are we doing this? Because we're going to get ready for logs, right? Whatever's in the log has to be positive. That's why we're doing this. Okay, let me clear it. All right, so this probably is what you're going to, this one thing you're going to see in your final in 1320, in 324. Changing from exponential to logarithmic form and vice versa is actually pretty easy. If you keep in mind that what I tell people to do is, you keep the base and you switch x and y, and then you're all done. That's how you do it. All right, so I'm going to rotate here. All right, so if I want to write this as a log in exponential form, the idea is I need the log, All right, first thing I do is write the base down. So the base is 5, that goes down here, and then I switch these guys. So the log base 5 of 25 equals x. So I keep the base and I switch x and y. Okay, and that's all you gotta do. Okay. And that's what she's saying here. Keep the base, right, and switch x and y. Okay. So let's talk about how to do that. Some more practice. All right, so if I want to write something in exponential form, let's do a few of these. Annotate. Okay, so what I'm going to do is I want a logarithmic. I'm changing a base, an exponent to a log, so I keep the base. The base goes downstairs, and I switch these guys. So log base 2 of 8 equals 3. Keep the base, switch x and y. So the next one, what's the base? The base is 3. Switch x and y. Log base 3 of 9 equals 2. Keep the base, switch x and y. Okay, so if I want to write this as a log, you got to be careful here because there's an x in it, but it's still the same thing. The base here, what's the base of this? The base of this is x. All right, the log base x of 10 equals 4. All right. Somebody, you guys still there? Let's see what's going on here, just because I can't see your faces and it's driving me absolutely crazy. I got 19, so 6 of you are gone. Let's see. All right, you guys still in there? I'm assuming you are. Okay. Okay, good. All right, so let's do another example. Can't get the thing up here. All right. So if I want to write this as a log, again, you keep the base. So it's log, the base is 7. It's the number on the bottom. Log base 7 of 8 equals x. All right. This one, the base is 4. Log base 4 of x equals 3. So I'm keeping the base and switching x and y. That's all I'm doing over and over again. So here again, the base is x. So it's log base x of negative 4 equals 3. I don't like this problem, because I told you can't take the log of a negative. So what this tells me is there's no solution to this, which is not, it's not really true. You can find a number that's cubed that equals negative 4. I don't know what it is, but this is no good because you can't take the log of a negative number. So that is not how you would solve that. I would solve it on the calculator just to show you there is a solution. X cubed equals negative 4, since we've been talking about solving things on the calculator. Oops, let me just go wipe this. So I'm going to type x cubed is negative 4. If I graph this, you should be able to see. Let me get an intersection here. Hopefully you'll see a solution. Sure, right. All right, the two curves cross right here, and I can find that solution. So I can find that with intersect, second calc intersect. So there is an answer to that, negative 1.58. It's just that logs aren't going to do it there because you can't take the log of a negative number. All right, so logs aren't perfect. Okay. All right.
So would we have to find that?
If you had to, you would have to use your calculator. So my point is, when you find yourself taking the log of a negative number, you could solve it with a log, right? So remember, you have options available.
Okay.
Now, I mean, some things don't have solutions. Like if I had x squared equals negative 2, there's no number squared that's a negative, right? So if I tried to solve that on my calculator, so let me just say x squared equals negative 4. So if I replace this with like x squared, and then graph it, you see that, well, okay, they're not going to cross ever. So that tells you there's no solution.
Okay.
Okay, so the point is, if you can't solve it with a log, I'll try something else, right? And really, honestly, the only way I can think to solve, well, you could take a cube root, but yeah. Okay. My point is, can't take the log of a negative or 0.
Okay.
Okay. Let me. Okay, so when we go to exponential form, we're writing it with an exponent. So we're getting rid of the log now. So it's kind of the same thing. You keep the base, you switch x and y. So when I look at something like this, the base of this is 3. And I'm going to write this 3 as the exponent. So 3 cubed is equal to 27. So I keep the base and I switch x and y. It's just that now it's an exponential. So this next guy, keep the base. This is your exponent. And that's going to equal 6. So you see, I just keep the base, switch y and x, and that gets me all the way through this. All right, so this guy, base is 2. So it's 2 to the negative 3 is 1/8. I just switch them. This guy, even though there's an x, I still follow the rules. It's 3 to the x equals 81. So you see, I keep them, keep the base, switch y and x. All right, and even if the base is x, all right, x to the third, it's 1,000. That's the exponential form of it. Keep the base, switch y and x. Okay, last one, keep the base, and switch y and x. So 4 to the 1/2 equals x. Okay, so that's really all you have to do to change forms. Okay. All right, so why do you change forms? Change forms to solve equations, all right? Because solving something like this, well, that's not bad, but I mean, I'm not looking for that. I'm looking for, well, let's make something up. Guys, 3 to the x equals 5. I don't know how to solve that because the x is upstairs, so I don't know how to do that. So when you have the x upstairs, you want to write it as a log, and then you can solve it real easily. Okay, so if I want to solve this expression for x, I have to get rid of the log, and the way to get rid of the log is to write it exponentially. So I'm going to do that real quick. So to write it exponentially, keep the base and switch y and x. So 3 to the 5th equals x, which is really easy. Now I can just plug it in a calculator, right? So 3 to the 5th is some big number. I'll just plug it in my calculator here. And I get 243. All right. So to get rid of a log, you write it as an exponential. Get rid of an exponential, you write it as a log. So like this guy here, to write this in exponential form, I'm going to say 2 to the, and I still just switch the thingies. So 2 squared is x minus 3. That's 4. And now I can solve it, right? If I add 3, I'm going to get x to 7. Okay. So you solve logs by converting to exponentials, and then you solve exponentials by converting to logs. So now we're going to go the other way. So there's several ways that people solve these. Some people take the log of both sides, which is just a waste of time because you have the log base button in your calculator. So when I have the x upstairs, like, you know, I can solve something like this. When the x is downstairs, I just take the square root, right? But when it's upstairs, I have to write a log. So the way I write it is a log. Remember, you keep the base. Switch these guys. Log base 2 of 17 equals x. And now I've got something I can just plug in my calculator. And I'm going to go to alpha F5, alpha F2. Log base, what was it, 2 of 17. And I get 4.08, basically 4.09. So what this does, it enables you to solve things where the x is upstairs. So like this one, same thing. I'm going to do a log base 4 of 64 equals x plus 2. Okay. Now you can plug this in the calculator. It's going to work out to be 3. And if you minus 2, you're going to get x is 1. All right, and you can check it, right? So if I plug in x as 1, I have 4 to the third equals 64, which it does, so I know it worked. All right, so logs are helpful in undoing exponents. Let's see, how do I clear this thing? There we go. All right, so, and that's it. So they stuck this weird section in the end for us, okay? And I'm not a real fan of it, but we need to go through it. There are log rules you want to know, okay, that you're going to be learning in 1324, and I'm going to make you a list of them. I need to go find that page. Really wish I could do this faster. All right, so, all right. So they only give you one log. I'm going to give you all the rules because it's so silly not to. And I think I have a quiz problem on a couple of these. So it's simple ones. No. All right, some things that I would know about logs. I don't care what the base is. The log of 1 is 0. We talked about it, but I'm just saying the log of 1 is always 0. And know that you can't take the log of a negative. Now, what are the log rules? Logs are like exponents, so they kind of follow exponent rules. So like when you have products, you add the exponent. So the log of a times b is the log of a plus the log of b. Okay, and it doesn't matter what the base is. The log of a over b, if you divide, you subtract the exponent. So it's log a minus log b. And I got one more that we're going to talk about is power rule. Log of a to the r. So this is like taking a power to a power, you multiply. So it's r times log a. So this just comes out front. Okay, so these are your basic log rules that you're going to be working with. All right, and they focus here on the power rule. Okay, in these notes. But I would know those 3 rules, these guys right here. Okay. All right. All right.
And all that was for 1324?
Yes. Okay. It's the stuff though, logs also, 324 logs are really an algebra thing. So, I mean, you might see some logs. Okay. To let you know that. On the 324 final, I know there's one convert from exponential to log or something like that. So that's why I went over that. Now the rules, it's just basic 3 rules, but for some reason they focus really heavily on this, which is kind of silly. This rule right here. All right. So when you have the log to power, the power comes out front. So like if I want to rewrite something using that log base 2 of x to the 5th, the 5 comes out front and it becomes 5 log base 2 of x. That's what they call the power rule. The power comes out front. Okay, now we're not going to do all of these because it's, like I said, kind of silly. It's the same thing over and over and over and over again. And I'll give you a couple practice with the other 2 rules just to show you what happens. Some very simple examples. We'll be doing more difficult stuff, but just simple. So when you have something to a power, the power goes out front. So this becomes 3 log base 2 of 5. This guy, 10 comes out front. So it becomes 10 log base 2 of 4. See, I'm just pulling the powers out front. There's nothing shocking, amazing about it. It's all the same. So, you know, when you have a power comes out front. This is 7 log base 2 of 8. Okay, so the power comes out front. You can also, just to kind of, if I had the log of, let's do 10x, 10x. So a log, a product turns into a sum. So if I want to turn into the sum, it's the log of 10 plus the log of x. So a product turns into a sum. I don't care what the product is. Right, this would be the log of 3 plus the log of y. The bases always stay the same. All right, so and when you divide, if I do 3 over y, the thing on the bottom you subtract. So it's log 3 minus log y. So when you divide, you subtract. When you multiply, you add. When you have a power to a power, just pull the power out front. So these are your three kind of main log rules that you work with, okay? Is that all right? Okay.
Gotcha.
Okay. So let me get through this. Clear. Well, here we go. All right, and I think is that it? Yeah, that's it. So for some reason, they just really focus real heavy on that 10.4 rule. So like I said, I'll let you guys know about the final. It should be the 9th and 10th unless they come back and tell me otherwise. And like I said, you're done your last test. All you got is 2 homeworks and a quiz this week, okay? Any questions about anything? Everybody good? All right, so I will talk to you on Thursday.
I actually have one. So if it's not on the 9th and 10th, what days will it be? You'll just notify
It'll
us.
be on the 5th through the 8th.
Okay.
So they sent an email out that said STEM classes finals have been changed to the 5th through the 8th, and I'm not sure if I'm STEM or non-STEM. I think I'm non-STEM, but I don't know. So I'm waiting to hear. Okay. So I will definitely let you guys know. I'll post it on the course homepage too. But like I said, final 20 questions multiple choice. It's not difficult. If you can do the practice final, you can do the final. All
Awesome.
right. All right. You guys have a good couple days. I'll see you on Thursday. Okay. Any of you guys left have any questions? Oh, take that as a no. All right.